So in today's Tech Talk, I'll be talking about PubSub messaging with Ably. So these are the things that I'll be discussing in this session. So we'll talk about what is PubSub messaging and some of the key components of PubSub messaging and what is real-time messaging, importance of PubSub messaging, and we'll also talk about some of the tools and frameworks of PubSub messaging, and we'll do a quick comparison on them feature-wise. And finally, I'll do a quick demo, which shows how you can use Ably to publish message to a particular channel and then subscribe to it and, get the messages from that channel. So first thing is what is PubSub messaging? So it is a communication model based on publish subscribe pattern. So this involves exchange of messages between the publishers and the subscribers through a central messaging system or a message broker. So how this works is, so you have the publisher which sends message to a particular topic. So then the message broker will distribute those messages to relevant subscribers. Those subscribers or those entities, they have to subscribe to these channels in order to receive the messages. So once they subscribe to the topic or the channel, they will receive the messages as soon as the publisher sends messages to the topic. This PubSub messaging is used in various domains. So these are some of them, like event-driven architectures, real-time data processing, and message queues and notification systems. So let's talk about some of the key components of PubSub messaging systems. So we have the publisher, or we can call it the sender. So basically, they generate and send messages to the message broker. So when they do that, they can determine the topics or the channels to which they are going to publish their message. And then we have the subscriber, which is those are the receivers, or those are the entities which show interest in receiving messages from a particular topic or a channel. So they, subscribe to that, and they get the messages from the publisher. And then we have the message broker. So it acts as the intermediary between the publishers and the subscribers. So they receive messages from the publishers and deliver them to the relevant subscribers. And then we have the channels and the topics. So these two kind of have the similar usage. So we use these to, categorize messages based on their context. But if you take topic, inside a channel, we can further categorize these messages using topics. So that's kind of like the main difference between channels and topics. So on this diagram on the right-hand side, you can see we have the publisher. So it publishes some message to a particular topic, and then all these subscribers, they have subscribed to this topic. So through the message broker, they will receive the messages. Then the next thing is a real-time messaging. So what is real-time messaging? So it is the ability to deliver messages and notifications with minimum delay. So this ensures that the subscribers receive the most recent updates, like from the topics they are interested in, from the most recent updates from the publishers as soon as they get available. There are some key aspects of real-time messaging. So we have instant message delivery, low latency, event streaming, and bidirectional communication. So the instant message delivery prioritizes the quick delivery of messages from publishers to subscribers. So when a message is published, it is rapidly transmitted to all the relevant subscribers, minimizing the delay between the publications and the receipt. And then we have the low latency, which is the time taken for a message to travel from the publisher to the subscribers. So this focuses on minimizing delays like the network latencies or system processing delays or any other factors that could introduce some delay in delivering messages to the relevant subscribers. And then we have the event streaming. So a continuous stream of messages or events is delivered to subscribers in real time. So this enables applications to react immediately to updates and events, so facilitating the real-time data processing and dynamic interaction. And finally, we have the bidirectional communication. In addition to only like the publishers can, the same way the publishers can, send messages to subscribers with real-time PubSub systems, it supports bidirectional communication as well. So now the subscribers can also respond to publishers' messages or events. Talking about the importance of PubSub messaging, we'll have loose coupling, scalability and performance, asynchronous communication, event-driven architecture, modular and extensible systems. So loose coupling is, so the PubSub messaging promotes loose coupling between components or systems. So the publishers and subscribers are decoupled. So they don't have to they don't need to know about one another in order to, communicate with each other. So it enables independent development of different components and making the overall system like more flexible and maintainable. And then we have the scalability and performance. Which means like the multiple subscribers can consume messages from a single publisher, which enables accommodating growing number of users and or consumers. So this also performs high performance message distribution, ensuring that the messages can be processed and delivered quickly, even in scenarios where you have to deal with high message rates. And then we have the asynchronous communication. So the publishers and the subscribers can operate independently without waiting for the immediate responses. So this is useful in scenarios where the real-time processing or near real-time updates are required. And this also allows components to react to events or messages as they arrive, so enhancing more responsiveness and the efficiency. And then we have the event-driven architecture, so which means the system reacts and responds to events or messages. So this enables like creation of loosely coupled systems that can easily integrate and adapt to changing business requirements. And then we have modular and extensible systems. So with PubSub messaging systems, systems can be built as modular or extensible architectures. So which means the new components can be added easily, or the existing components can be removed without actually affecting the overall system, as long as like they adhere to the existing messaging format and the communication protocols. Um, so yeah. And so these are some of the tools and frameworks related to PubSub messaging that you can use. So we have Kafka, RabbitMQ, Google Cloud's PubSub, AWS SNS, Nats, and Ably. So I have included this table, comparison table. We can compare them on feature wise. So I have listed down some of the features here as well. So we have already talked about PubSub model. So we'll talk about message ordering. So actually the PubSub model, all these tools or frameworks, they support it. But when it comes to the message ordering, which means the ability to maintain the message order of or the order of the messages within a specific topic or a channel. So this ensures that the messages are delivered and processed in the same order in which they were published. So if we by this, preserving this message order, we can guarantee that our subscribers receive and process messages in a sequential manner. They are not like the context of the conversation is, we can ensure that the context of the conversation is maintained. Google Cloud, PubSub, Ably, and Kafka supports this. And I think we already talked about scalability, so we'll move on to persistence. So it is the ability to store and retain messages even after they have been delivered to subscribers. So this ensures that the messages are not lost in case, let's say, the subscribers are temporarily offline, or for some reason they were not able to, process them immediately. So in that case, they make sure that the messages are not lost, so they can and make them available to them whenever they become available. And then message routing, so which enables the selective delivery of messages to specific subscribers. based on their predefined rules. So this allows subscribers to send messages to publishers to send messages to specific destinations or channels, ensuring that only the intended subscribers receive the messages. And the next one is message filtering. So this allows subscribers to define specific roles to filter and retrieve only the messages that match their requirements. And it also enables them to receive a subset of messages based on the content or the metadata. So, like I said, ensuring that make sure that they receive only the messages that they need. And then we have the language support, which refers to the availability of client libraries or SDKs or APIs that support multiple programming languages. So this enables developers to interact with the messaging systems using their preferable programming language. And then we have the integrations. So it is the ability to integrate with these messaging systems with other technologies or services or platforms. And we have push notifications. So it enables real-time notifications or messages to mobile devices, web browsers, or other applications. So they allow applications to proactively push messages or updates to the subscribers, ensuring the timely delivery of the information. And I think we already talked about real time. And the event history is the ability to store the history or log of events that have occurred within the system. So this will allow the subscribers and to retrieve the past messages or events that were published before their subscription. So they can, once they subscribe to this, they will receive the messages which were published before they subscribe to the relevant topic or the channel. So I did a small demo here. I'll just move to this. So this is what the application which I created. So we have here some choices. So we can, so when I click on one of these events, it will automatically get, this chart here will get updated as I, click on these events. So what's happening here is, so in this form, we are publishing by clicking on these buttons, we are publishing a message to the channel, and then on this side, the graph side, it is subscribing. It has subscribed to that channel. So as soon as a message gets published to this, it will get updated. So I have done this using Ably. So you can see it updates content as soon as I publish some info to this channel. So how I did this was so this so here's the form, a simple form, and so I have used the ABCDN here. In order to use it, you have to use that. So and then you can by using Ably, you can you can create a free account and you can create a API key just to try this. So I have created the a free account and I have used the API key here. So in order to initiate this real-time library, here's how you do it. You call the create an instance of this real-time library by passing the API key here. And then we are going to create the channel here by using that instance. We call the channels.get method. So this method, it will check if there's a channel already created with this name. So if it is there, it will fetch that channel for us. If not, it will create a new channel with this name for us. And once we create the channel, here's how we publish it by using the publish method. You can publish messages to the channel. So under this channel, we are creating another event called bot. So we are publishing the messages to this event, bot event. So we have these on-click events. So whenever we click these buttons, some message will get passed to will get passed to here. So that will get published to the channel. So on the other side, just the chart side. I have used a Fusion chart for this. So here on this side also we have to initialize the library, real-time library by using the API key, and we get the channel, and then using the subscribe method, we can subscribe to that channel. So you can see here's the event name, and so that's how we subscribe to the channel. We create the channel, and from there we subscribe to the event that we want. And so from there, we update the chart based on the message that will get published to the channel, and we will update the chart. So that's how it's a small application that I created, but I think it will help to like get the basic idea. So that's pretty much it.